Looking at the next example, we're playing with the summation of I equals 1 to 10 of I minus 3 quantity squared. Now the fact that that is quantity squared actually causes a lot of problems for us. The fact that there is a squared on it doesn't say that we can actually use this thing here. This only works if it goes from 1 to n of just I. And you'll notice it goes from 1 to n of not just I. So for me to actually use the formulas, I'm going to actually do one of two things. Either I have to transition this thing so that it's just I squared, but then the bounds would change and I wouldn't start at 1, which means I still can't use these formulas. Or I might as well just be lazy and multiply this stuff out. So this summation is nothing more than the summation of I equals 1 to 10 of I minus 3 times I minus 3. And we're going to FOIL that out. So this summation is equal to the summation of I equals 1 to 10 of I squared minus 6i plus 9. Again, you are allowed to do any algebraic manipulation inside the summation as much as you want. But be very careful about taking anything from inside the summation outside the summation without following the basic properties of the summation rules that we have. So now that I'm here, the rules that I have tell me I can separate this summation from this summation from this summation. The rule also tells me that I can take the 6 out of this summation and treat this 9 as a constant. So, very carefully, I'm going to identify the formulas here, and I'm not going to write down the intermediate details. I squared. If I go from 1 to 10 of I squared, it's going to be this formula where all those n's are 10s. So this I squared piece becomes 10 times 11 times 21, all divided by 6. Again, 10 times 11, 2 times 10 is 20, plus 1 is 21, all divided by 6. So that's your I squared. I'm going to carry down the subtraction. I'm going to carry down the minus 6. Now the summation of just I is this thing right here. The summation of I is this thing right here, where n in this case is 10. So I'm going to replace all of those n's with 10. 10, 11 over 2. And then I have a plus, and then 9, which is my constant, times my n value. My n value is 10. So you'll notice very carefully that we do have all of these pieces, and notice there is no more summation, because the summation of I squared is this, the summation of a negative 6i is a negative 6 times this, and the summation of 9 is 9 times 10. Again, we can do this as efficiently as possible. I would argue that the most efficient way to do this is to start by factoring out 10 from all three of these pieces. The next thing that I would say is most efficient is for us to realize that 6 and 21 can simplify down, giving me a 2 left over here and a 7 on top. So 11 times 7 divided by 2. Here I can argue that the 6 and the 2 can cancel out, but I might actually just want to leave that to be 6 times 11 divided by 2. And I'm going to actually go ahead and do that. So it's 6 times 11 divided by 2. And then finally plus a 9 tacked onto the end there from this piece right here. Now these two pieces here I can simplify as much as possible. Again, you might have wanted to simplify this, but I'm noticing that this is going to be 77, this is going to be 66, and it's going to be all divided by 2. And 77 minus 66 is nothing more than 11 over 2. So this becomes 10 times 11 over 2 plus 9, in which case I can go ahead and very quickly do this as 18 over 2, giving me 11 plus 18, which is 29 over 2, times 10, ending with 29 times 5, which again you can go ahead and do that really quickly as being 125 plus 20, so something along the lines of 145 if I'm not mistaken. In this last example right here, you're going to do again the exact same things we did in the last example, but this time it's already all multiplied out and torn apart. You can separate right down this plus sign. There's this term and there's this term, and we're going to go ahead and use these pieces right here. Now the unfortunate part about this one is, notice, we end with n. So all we are able to do is replace our variables I cubed with the appropriate formulas. 3 times n squared times n plus 1 quantity squared divided by 4, plus, again there's my separator, plus 4 times my I squared term being this n times n plus 1 times 2n plus 1, all divided by 4. Now again, there's more that we can do mathematically with this. For instance, we can cancel out these 4s. We can combine things as much as possible. By what I mean by that is factoring out a 4 on the denominator and an n and an n plus 1 on top, and hopefully simplify down what's left. But again, I don't see that as really a necessity. I will at least write the first step for simplifying in case we have to later. And the rest of this is going to be 3n plus 1 plus 2n plus 1 times 4. And again, we can very easily simplify this and then distribute that in where we need to. But that, again, will simplify this as much as possible to the best of our ability that we might need. And you'll see in later examples that the n's will hopefully cancel everything out.